Good day everyone! At this video, I will discuss to you the acid-base equilibrium and salt equilibria.
This lesson is divided into three, namely, Lesson 1, Bronsted-Lowry acids and bases, Lesson 2, the acid-base properties of water, and Lesson 3, the pH scale. Before we will go further, I will read first our objective for this discussion. First, define Bronsted acids and bases. Second, discuss the acid-base property of water. Lastly, calculate pH from the concentration of hydrogen ion or hydroxide ions in aqueous solutions. Determine the pH of a solution of weak acid or weak base. Lesson 1, Bronsted-Lowry acids and bases. Bronsted-Lowry acid is a substance that releases or donates proton or hydrogen ions in solution. In our case, HCl or hydrogen chloride. However, a Bronsted-Lowry base is a substance that accepts proton or hydrogen ions in solution. In our case, water. Example: we will figure out which substance acting as an acid or base. In this example, water acts as a Bronsted-Lowry acid because it releases proton. On the other hand, ammonia acts as a Bronsted-Lowry base because it accepts proton. In addition, when a Bronsted-Lowry acid loses a proton, a conjugate base is formed. Similarly, when a Bronsted-Lowry base gains a proton, a conjugate acid is formed. Like this example, HF lost or donated a hydrogen to water, thus it is the Bronsted-Lowry acid, and since water accepted the hydrogen, so it is the Bronsted-Lowry base. The hydronium ion is considered as the conjugate acid because it was added a hydrogen molecule, and fluoride is the conjugate base because it loses or take away a hydrogen molecule. Lesson 2, the acid-base properties of water. Water is a universal solvent. It is so unique that it can behave as both an acid and as a base, and this is called amphoteric. It can also create ions just by itself, and this property is called autoionization, and this process only occurs in 25 degrees Celsius. Water has its own constant, which is the ion constant product, also known as Kw. In pure water, at 25 degrees Celsius, the concentration of hydrogen is equal to 1 times 10 to the power of negative 7 m. Also, at this temperature, the product of the concentration of hydrogen and hydroxide is equals to 10 times 10 to the power of negative 14. If the hydrogen is greater than 1 times 10 to the power of negative 7, then the solution is an acid. If the hydroxide is greater than 1 times 10 to the power of negative 7, hydrogen is less than 1 times 10 to the power of negative 7, then the solution is a base. If the hydrogen is equal to hydroxide is equal to 1 times 10 to the power of negative 7, then the solution is neutral. Lesson 3, the pH scale. The pH is used to better measure the acidity or alkalinity of a substance. It is the negative logarithm of the hydrogen or hydroxide ion concentrations. It is a scale measured from 0 to 14. A pH lower than 7 indicates as an acid solution. pH greater than 7 is alkaline. And if pH is equal to pOH is equal to 7, then the solution is neutral. Also, we can tell if something is acidic, alkaline, or neutral by using an indicator. Indicators are substances that show different colors. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus is red in acids and blue in alkalines, which means red litmus paper changes its color to blue under alkaline condition. On the other hand, blue litmus paper changes its color to red under acidic conditions. Moreover, the greater the hydrogen ion concentrations, the lower the pH and the more acidic the solution is. If the pOH or hydroxide is given, then the pH can also be determined knowing that 14 is equal to pH plus pOH. Here is the picture of pH scale. Here are the following formulas. pH is equals to negative log times hydrogen ion, or pH is equals to hydronium. 14 is equals to pH plus pOH. Kw, or ion product constant of liquid water, is equals to hydrogen ions times hydroxide. pKw, or negative log base 10 ion product constant of liquid water, is equals to pH plus pOH. Since Kw is equals to 1 times 10 to the power of negative 14, then pKw is equals to 14. 14 is equals to pH plus pOH. Example, what is the pH of the solution if the hydronium ion concentration is 2.5 times 10 to the power of negative 4 m? Is the solution acidic or alkaline? What is the pOH and the hydroxide concentration? Given, hydrogen ion is equal to 2.5 times 10 to the power of negative 4 m. Equation, pH is equals to negative log times hydrogen ion. Now, let's substitute the given value. Negative log times 2.5 times 10 to the power of negative 4. So our pH here is 3.6. Thus, the solution is acidic because it is less than 7. Now, let's proceed in getting our pOH. pOH is equals to 14 minus pH. Since our pH is 3.6, we need to substitute our pH here. So 14 minus 3.6 is equals to 10.4. So our pH is 10.4. Now, let's proceed in getting our hydroxide concentration. So hydroxide concentration is equals to 10 to the power of negative pOH. So our pOH is 10.4. Again, let's substitute our pOH here. 10 to the power of negative 10.4 is equals to 3.48 times 10 to the power of negative 11 m. So that concludes our discussion for this video. I hope you've learned something. Thank you for watching and have a great day.